From the June-July 2022 series, we had question number, let me check, it was question number 2A, which said determine the first four non-zero terms using Maclaurins Theorem, expansion of the function fx equals to e sin x, then hence evaluate the integral from 1 to 2 of sin exponential of sin x, then divide by x, dx to 3 decimal places, and you are given 10 marks to work with. So now let's see, how do you work out such a question? So the first thing you need to identify is to identify your type of a function, right? So we have an exponent function and we have a sine function. Basically, you should know that this one is a function of a function. That is, sine x is inside the function exponent. Are we together? So the solution. So first of all, you need to know that our function is indeed a function of a function. So therefore, our f of x is given by e sine of x. Now replacing this one equals to 0. So f naught shall have what? Sine of 0 is 0, and anything to power 0 is what? 1. Okay? We shall have, remember I'm saying, we shall have e, okay? Then sine of 0 will be 0, and anything to power 0 is equals to 1. Now let's differentiate our function here. Okay, so we shall differentiate our function. So we are saying using the chain rule. So I'll use, let's just go procedurally here, using chain rule. So using chain rule, we shall have a function. We shall have this function written in terms of y. Right? So we shall say our function here is given by y equals to e sine of x. Right? Now, then we let the function that is inside another function to be u. So we shall let our u function here to be sine of what? Sine of x. So sine of x. So if our u is sine x, our new y will be given by what? Our new y will be given by e. The whole of this is u. Are we together? So then we shall have u. Alright? Now, by chain rule, what we say is you just multiply the derivative of this multiplied by the derivative of this. So here we are going to be getting du dx, alright, in the first place. So u prime, we shall say u prime will be given by, when you differentiate sine, what do you get? You get cosine. Cosine of x. When you differentiate an exponent function, you always drop the power. So y prime, so we'll write it as that. So y prime, what is our value here? Our value here is just 1. So you drop 1. Just you drop 1, then you rewrite your exponent function, right? So when you drop 1 here, you shall just have 1. Then you shall have 1. Okay, you shall drop 1. Then you have an exponent of u, which still gives you an exponent of u. So therefore, the derivative of this function here will be given by the multiple of this prime and this prime. Are you together? So our first derivative in this case, f prime x, will be given by the multiple of this and this. So what is our u prime? Cos of x. Are you together? Then this function here, which is eu. But we know what our u is. What is our u? Our u is given by what? Sine of x. So every time we shall be using the chain rule, remember, always remember that we have the part of u which is supposed to be replaced to be in terms of x. So you replace your u with what? With sine of x. So therefore the derivative for this will be given by that. Then therefore, so the first derivative therefore, you replace your 0. What will you have? When you replace 0 here, this becomes 1. Are you together? And you have already seen that this part here, when you replace 0, it becomes exponent to power 0, which is also 1. So 1 times 1 will give you what? Will give you 1. Right? Now, let's come to the second derivative. Now, notice something here. We have this part here, and we have this part. Now, these are function on its own, then this is another function on its own. So we are multiplying two functions. So what will we use? We shall use the product rule. And the product rule says that you're going to get uv prime or vu prime, then this uv prime, then vu prime. So you shall take one of your function to be u, the other function to be v, right? So we shall have, so if we take, we let, now in this case we shall let our u to be the cosine of x, and then we shall let our v to be the exponent sine of x, right? Your u prime is the derivative, are you together? Your u prime is the derivative, so when you differentiate cosine you get negative of sine of x. When you differentiate v prime, we already know the differential of this. The differential of this is the whole of this. So we shall have, the whole of this becomes cos of x exponent sine of x. So by product rule, right? By product rule, we have uv prime. So what is our u? Cos of x. So f double prime of x will be given by u is cos of x, right? U is cos of x. Then we have v prime is this. So again, we'll have cos of x, then exponent sine of what? Sine of x, then plus our v. What is our v in this case? Exponent of sine of x. Then your u prime, what is your u prime? Negative of sine. So negative of sine x. So this one gives you cos square x, then exponent sine of what? Sine of x minus, because of this negative here, so that you can just start with the sine, then sine of x, then exponent of sine what? Of sine of x. Are you together? Yes. So therefore, now we can replace the second derivative. So remember, let me just put that, so we have that, we have our f naught, we have our f1. Therefore, the second derivative now replacing 0 everywhere. So this one replacing 0 here, we just have 1. This one will also give you 1, so we'll have 1. Alright, so we'll have 1. Minus. When you replace the sign of 0 here, we have a 0 by the end of the day. So whatever, this one is 0, and this one will give you 1. Are you together? Because the sign of 0 is 0. Then exponent to power 0 is 1. But the sign of 0 is 0. So the whole of this becomes 0. So you have minus 0. So remember here we're getting, just be precise. So we're getting f double prime of 0. So we are saying the whole of this part becomes 1. The whole of this part becomes 0. So it also gives you 1. Our second prime was given by this here, this function here. So I'm sorry for the board, it's quite spacious. So we have this part. So this is our second prime. Now remember this part here, let me just rewrite it here again. X is given by, the cosine squared of x can be written as cos of x, then into bracket, squared, exponent sine of x, then minus sine of x, exponent sine of x. Alright? Now, this is a function, this is another function. Are we together? This is a function, this is another function. Then you have another function and another function. So again, we shall use product rule. Now, in this case, just go direct to how we're going to do this. Now, this one is a function of a function. Are we together? This one is a function of a function. So basically, we can multiply it by a function of a function for us to get the derivative of this. For this part, we know how to get the derivative, and it's already given here. We have this part, is another function. So we can solve them in parts. So what will be the derivative of this? So we shall let, again, for this part here, so we shall split them into 2. So we take, let's solve this first half together. So our f, so we shall let our u to be cos of x, then we have squared, then our v to be given by e sine of x. So we are solving for this part, right? Then u prime, then v prime. Okay, now we are using the product rule. So when you differentiate this, what did I say? drop the power, reduce the power by 1, then differentiate whatever is inside. So drop the power, we shall have 2. Reduce the power by 1, so you shall just have your cosine of x. Then if you reduce it by 1, it just becomes cos x, right? Just that. Then differentiate whatever you have inside here, which will give you sine of x, right? Then you have your v. Differential for this part is just this part. So it will be given by cosine of x, then exponent sine of x. So therefore, putting that together, we shall have u v prime v u prime. Therefore, this one will give you, so u v prime plus u v u prime we shall have, so this part shall have, what is our u? Our u is our u, now this, cos x squared, what is our v prime? Cosine of x, exponent of sine of x, then plus, what is your v? Your v is e sine x, then what is your exponent? You have 2 cosine of x sine of x. Now this is for the first part. Then you have this part here. Then for the part 2, we shall have sine of x, exponent sine of x, right? So again, let this one to be u, become sine of x, your v to be exponent of sine of x. So your u prime will be given by cosine of x, your v prime will be given by this part is given by this. So we will not differentiate it again, so that, then exponent of sine of x. Now multiplying the two, we shall have u v prime cos of x exponent sine of x, then plus v u prime be given by that. Basically, you can just see we're just like cross multiplying. This multiplies with this multiplies with this multiplies with that. So basically, here we shall just have. I think it is okay, well arranged. So now putting all this together, so we shall have sin x, cosine of x, exponent of sin x. Then this can come at the beginning, so cosine of x, exponent sine of x. Alright? So now putting all this together, so we have the derivative of this part, which is given by the whole of this. Then the derivative of the second part will be given by the whole of this. Now putting them together, so we shall have this term, then subtract this term and this term. So this term, when you open the bracket, will just be in terms of subtraction. So at this point, I can just take these terms and this term, and I just replace with f naught. So your function f of x, that is the triple, alright? So the third derivative of x, now I can just replace it with 0. Because remember we are saying it will be this part, which is the whole of this part, the derivative of it, minus the whole of this part, which is given by this. So together. But now remember we shall have a negative because you're subtracting. So this will be negative, this will be negative. So now let me just replace the zeros so that you can get our values. Right? So here when you replace a 0, you shall have 1. And here we shall have 1, we shall have 1. So the whole of this just becomes what? Just becomes 1. Then plus the whole of this, the aspect that you have a sign here, the aspect that you have a sign at the denominator, the whole of this becomes what? Becomes 0. Alright? We shall have 0. Then minus. Let's take whatever we have inside here. The aspect that you have a sign here, alright? The aspect that you have a sign here, at the end of the day, it gives you what? 0. Then plus. Now we have a cos, this will give you 1, then this will give you 1, so we shall have 1. So therefore, 1 plus 0 gives you 1. 0 plus 1 gives you 1. So 1 minus 1, then it will give you 0. So your f triple 0, your answer will be what? Your answer will be 0. Are we together? So therefore, we can now write our expansion. And our expansion will be given by, so let me wrap this, and we now write our expansion. So we have our first, our f naught is given by 1, our f prime naught is given by 1, our f double prime naught is also given by 1, right? It's here. Then our f triple will be given by what? It will be given by 0. So now writing the whole this, all of this we can have as our expansion. So our expansion will be given by, so the expansion for e sine x will be given by, so we shall have our first term is our f naught, and our f naught gives us 1, right? Plus x, our first derivative also give us 1 or 1 factorial. Then plus x squared, our second derivative give us 1, then over 2 factorial. Then our third derivative give us what? Give us 0. So we have our first 4 terms. Now we can simplify that. We can have 1 plus x plus what? This is 1. So we shall just have 1, which is just x squared at the end of the day. Then over what? Over 2 factorial is just what? 2 factorial is just 2. So the expansion for exponent of sine of x, which is just a function of a function which is given by 1 plus x squared plus 2. Then from this point we can now solve the second part and see what it gives us. So let's solve for this second part. So therefore we check this. So rewriting this, so point 2 is the integral from 0 to 1 over e sine x divided by x, then dx, and 3 decimal places. Now rewriting this again, we shall have from 0 to 1. The expansion for e sine x is given by this, so it's 1 plus x squared over 2. So we have that. Then divide by x and dx. Alright? Again, we can remove this x here and bring it in the numerator. So we shall have, now this is 0 to 2, it is 1 to 2, sorry. 1 to 2, then we have 1 to 2. So we have that, alright? Now taking this, the denominator we shall have 1, 2, then we have 1 plus x squared over 2 into bracket x. Our power here is 1, so it comes, the denominator becomes negative 1 dx. Now this x can multiply with everything there, so again we have from 1 to 2, so this and that gives you x negative 1, right? Plus the power here is x to power 1, right? Then you add x minus 1, so 1 minus 1 gives you what? 0, and anything to power 0 gives you what? 1. So this term here will become 1. Right, together, because we have x1, right, multiplied by x minus 1. So adding 1 plus minus 1, which will give you x power 0, and anything to power 0 gives you what? It gives you 1. So this one becomes 1, then plus. So 2 plus minus 1 give you 1, right? So it just gives you x over what? X over 2. Then all of that you now integrate with respect to x. So therefore again, increase the power by 1 divided by the new power. So we should have first term, increase it by 1. Okay, so it is negative 1. So plus 1 gives you what? 0. Alright, together. Then divide by the new power. You can never divide a number by 0. So basically that gives infinity. So you cannot define. Basically, this is basically undefined. You cannot define it because you increase it by 1 becomes 0. Then divide by 0. Thou shall never divide a number by 0. So that cannot be defined. Then you come to the second part. We shall have just what? We shall now include our x, because if you were to write our x here, it is x to power what? 0. Now increase it by 1, it becomes x to power 1, and x to power 1 is what? X to power 1 is x, so it just remains as x. Basically what you're saying is, if you don't have the variable of integration, just introduce it where you have a constant. So this becomes x, then the second one, and the third one becomes x, increase by 1 becomes 2, then divide by 2. So you shall divide by 2 and you have a 2. So you shall have what? 2. So therefore, putting the upper limit and the lower limit, so replacing 2 here, so you shall have 2 minus 2 squared gives you what? 4. 4 over 4, so it is plus, sorry. 4 over 4 gives you what? 1. Minus, replace 1, so you shall have 1. 1 squared gives you 1. So 1, you shall have 1 over 4. So this basically will be 3 minus 1 and a quarter, which will give you 5 over. And what will be 3 minus 1 and a quarter? So 3 minus 5 over 4, which will give you 1 and 3 over 4, which is 7 over 4. Which is the same as what? 1.75. And that will be your value for the expansion of exponent sine of x.